Good morning, students. Am I audible to you?
Morning, sir.
Good morning.
Good morning, sir.
Good morning.
Sir, good morning, sir. This is Vinod.
Yes, sir. We know, sir.
Yes, sir. Just 2-3 minutes, sir.
Sure, sir.
Yes, sir.
So, till all these students are gathering up, would one of you tell me that you have already studied center of mass, right?
Yes, sir.
So
Yes,
you have
sir.
a basic idea about what center of mass is and how to. Okay. So we will do some more questions in center of mass, and I will give you another some basic ideas about center of mass also. Center of mass is a quite an important chapter. When it comes to JEE or NEET, you can always expect at least.
நீங்க எவ்வளவு அதான் நான் நோட்ஸ் எல்லாம் எழுதிடுவேன் நோட் மட்டும் எடுத்துவா
Children, good morning to everyone.
Morning, sir.
Morning, sir.
Good morning.
Happy
sir.
morning to all. Today you are lucky students. Already you have attended the physics class. I would like to welcome Mr. Sumit Pari sir to give a wonderful session regarding the physics subject. Sir, welcome you, sir.
Thank you, sir.
Children, you all of you be attentive and you have to utilize the class. Whatever the doubts you have after complete the class, you can raise, are ready to discuss and clarify your doubts. Okay, so be attentive with the class and interactive with the class. Sir, please. Thank
Okay.
you, sir.
Thank you so much, sir. Okay, so students, we are starting with center of mass. Center of mass. Okay. Now, first let's get an idea of what center of mass is. Let's say we have an irregularly shaped object. Okay. Now, if I want to, place it on, let's say, supports. Okay. Right now in this position, do you think this object would be stable on this support, just this one single support?
No, sir.
No, it would try to fall down like this. Okay. So if now I place another support over here, now will it be more stable or less stable?
Sir, more stable.
It will be more stable. Okay. So usually in general case, if we want to support any object, we need at least how many support points?
Two supports.
Two support points. Okay. Now, let's say, what if, I tell you that, there is one unique point, let's say there is one unique point inside this object where if I place a support right underneath that, if I place a support, just one support, I will remove these two. Okay. What if I tell you that there is this unique point where I can support the weight of the entire object at a single point? Okay. That point is known as what? The center of mass. That point is known as what? A center of mass. Okay. So we'll write a very small definition of center of mass, that we'll say it is a unique point. Unique, that there is only one of it. There are no two center of masses, right? So it's a unique point where the object can be supported by just one support. This is called a support. Just by placing one support, the entire weight can be balanced or it can be supported, right? As children, you might have, may not have done this. Okay, you might try. If you have, let's say, a ruler, a scale, okay, the one which we use in geometry. Okay, usually it's of a uniform mass distribution. So let's say if it's of a 30 centimeter length, 0 to 30, where do you think you should place your finger underneath so that you can balance this on your finger, just one finger? If you want to place at the 15 mark, right? At the if 30 centimeter scale, if you place your finger, let's say this is your finger. If you place your finger underneath the 15 mark, can you support this like this?
Yes, sir.
Okay.
Yes, sir.
Now, obviously, the ruler is of a uniform mass distribution. That's why we are assuming that the center of mass lies at the very center of it. But let's say if we replace it with another irregularly shaped object, like imagine we have, a long walking stick. See, old people you might have seen that they carry a walking stick with them. So if you have a walking stick, is it a uniform mass, student?
No, sir.
No, it's not a uniform mass. So let's say it has a center of mass here. Again, we can do this entire balancing act by placing our finger underneath this and it will balance. So what is happening is the concept of torque. I don't know if you have already studied torque or not, but we'll study it later on when we understand rotational mechanics. So this part of the weight is trying to pull the object this way. And this part of the weight is trying to pull the object this way. And about the center of mass, these pulls or these torques are getting balanced. So why an object gets stable under the center of mass? Because the entire pull which the mass is generating is getting balanced. So this is the concept of center of mass. Another aspect of center of mass can be understood by the fact that if we take this same irregularly shaped object, let's say this is our irregularly shaped object, and if we suspend it vertically, okay, understand correctly, if we suspend it vertically like a pendulum using a hinge, this point is called a hinge. Okay, it's like putting a nail into the wall and hanging the way we hang paintings or the wall clocks on the wall. That point is called a hinge. So if we suspend an object, irregularly shaped object, on a hinge, what happens is the center of mass, wherever it is, the center of mass, wherever it will lie vertically below the hinge. Note down this fact that if we suspend an irregularly shaped, any shaped object about a hinge, if we suspend an object about a hinge, the center of mass will lie vertically below the hinge in equilibrium. So when this object becomes stable, it is not oscillating anymore. Where will the center of mass be? It will be directly below the hinge. Okay, so that's another property of center of mass. Have you noted it down, students?
Sir, can you repeat the sentence once
Okay,
again, sir?
I will repeat. Okay, if an object is suspended, about a hinge, comma, the center of mass will lie vertically below the hinge, in equilibrium. Okay, I will convey this with one more example. Let's say if we have a rod and if we hinge it like this, the hinge is placed at the lowest point, let's say, and the rod is free to rotate in a vertical plane. The center of mass right now is above the hinge. Do you think this rod is stable or unstable? What do you think? This rod is stable or unstable? If I disturb it, will it maintain this vertical position or will it fall down?
The fall down.
It will fall down. Okay, and when it falls down, finally it will come in this position. Where the center of mass readjusts to where? To below the hinge. It will readjust itself to below the hinge. So what do we learn from this? We learn that when is a body stable? When the center of mass is as high as possible or as low as possible? As low as possible. Okay, and if there is a hinge involved, the body is only in equilibrium, only in stable equilibrium when the center of mass is vertically below the hinge. Okay, if it's vertically above the hinge, there might be equilibrium, but that equilibrium won't be a stable one, right? So two things we are learning from this. If we want to keep objects stable, we should keep the center of mass low as possible, as low as possible. And if we want to have a stable equilibrium and there is a hinge involved, where should that center of mass lie? It should lie below the hinge. Okay, note this down. We'll take just one other example and we'll come to the numerical formula for center of mass. Right? Noted this down, students?
Yes, sir.
Okay. Now, just to give another example of stability, having a low center of mass. Okay, all you must have seen different kind of vehicles. We'll take example of two vehicles. One is a truck, and another is a sports car. You can imagine any sports car, a Ferrari or a Lamborghini or anything, right? Like that. Okay, which do you think is more stable at high speed, a truck or a sports car?
Sports car, sir.
A sports car, right? Now the reason behind this is center of mass. A truck, because it is a tall design, it has a high center of mass. Whereas a sports car, it's a low design. It's spread more horizontally than vertically. The mass is spread more horizontally than vertically, so it has a low center of mass. So when it is traveling at a high speed and you have to take a turn, which will be more stable, a truck or a sports car?
Sports car.
Sports car.
Sports car.
A truck moving at a high speed should ideally never take a sharp turn. Why? Because there is always a danger of toppling down, and we will discuss toppling in very minute detail when we discuss rotational mechanics and torque and all, right? So don't worry about that. So how to locate the center of mass? This is the numerical part we are going to cover, how to locate the center of mass. I'll use a short form of center of mass, COM. So how to locate the center of mass. Now in this, we will come across two kinds of questions. One is discrete mass. Discrete mass. This means point masses which are spread around in space, discrete mass. And another will be continuous mass. Continuous mass distribution. So the kind of distribution there is, we have to first think about it. Like, is the mass distributed like this? This is a discrete mass distribution. All the masses are point masses and they are spread around in space. Whereas a continuous mass distribution, sometimes it is also called a rigid body. It is called a rigid body. So if it's a disk, see, or it's a rod or a cone, any shape where the mass is continually distributed across an area, a line, or a volume, that is called a rigid body. So whenever we come across a question, we'll ask ourselves, is this a question of discrete mass or is it a question of continuous mass? Just note this down, then we'll start with discrete mass, right? Done?
Yes, sir.
Okay. So first we'll discuss the discrete mass part. Okay. Now let's draw a coordinate system. Okay. Let's limit ourselves to two-dimensional plane right now. We have one mass. Let's say this is M1, and it's located at a vector position R1. There is another mass M2. It is located at another position vector R2, right? Now there can be any number of masses in this space, and the formula for position of center of mass is sigma mi ri vector over sigma mi. Now what do you mean by sigma? It is a continuous summation. So in this case, what we will write is m1 r1 vector plus m2 r2 vector. Now if there are more, we'll continue this till the number of particles we have, and we'll divide by the sum of the masses m1 plus m2 up to the number of masses it has. If it has n number of masses, it will go to mn, right? Note this down. And we'll just talk about this formula. Where does this come from? We'll just have a basic idea about it and we'll move forward. So m1 r1 vector plus m2 r2 vectors. I hope you are familiar with vectors and you are comfortable with using vectors, right?
Yes, sir.
Okay. because vectors only involve, directional coordinates, I cap, j cap, k cap, and there is a concept of positive and negative in the vectors. So I hope you can handle that. So m1 r1 plus m2 r2 over m1 z2. Now this ratio sigma mi ri, what sigma mi? This ratio is called a weighted average. Weighted average. I'm pretty sure you all know what average is or mean is, right? A simple average, I believe already everybody knows what a simple average or a mean is, right?
Yes, sir.
Okay. Weighted average is only slightly different from a simple average. Let's say I have some numbers n1, n2, n3. If I ask you what is the mean of this set, so you will say the average will be n1 plus n2 plus n3 over 3, right? But when we say weighted average, we don't just simply add these numbers, we give them some weightage. I'll give you an example. Let's say n1, n2, n3 are the marks a student is scoring in 3 different subjects. Okay. And those subjects are, let's say, physics, and let's say Sanskrit, and let's say physical education. Sometimes you have a physical education subject also in schools. So let's say on basis of these 3 subjects, you are applying for a science college. You're applying for a science college. Which subject do you think should have the most weightage?
Physics.
Physics, obviously. See, now, if I take a simple average of these 3 numbers, will it be fair to the students who are scoring more in physics?
No,
No?
sir.
No, obviously. So we'll give them weightage. How? I'll give this a weightage of M1, this a weightage of M2, and this a weightage of M3. Obviously, M1 will have the largest value. So now, how do I score you on this basis? I will say M1 N1 plus M2 N2 plus M3 N3 over the entire weightage, that is M1 plus M2 plus M3, right? So this is the process of finding out the weighted average. Now, why are we taking weighted average when we are talking about center of mass? So if I ask you a very simple question, where do you think the center of mass of a body should be? Should it be where the largest part of the mass is, or where the lightest part of the mass is?
Largest.
The largest or the heaviest part of the mass. Okay, so center of mass is biased towards, or it is found towards that part of the body which contains the heaviest or the largest masses, right? So I can't take a simple average of R1 and R2. R1 and R2 are the positions. I can't just say R1 plus R2 plus R3 by 3. No, I have to give weightage to the masses. So which part will contribute most towards the location of center of mass? The one which has the largest mass. That's the simple idea behind weighted average of center of mass. See, if I have n number of particles contributing to a center of mass, which particle will have the largest contribution? The largest particle, the heaviest particle will have the largest contribution. So it's a fair system in which we give weightage to the largest mass, right? So that's how we come to this formula. There are another ways in which we can derive it, this formula, but I think one is enough. Okay, so we'll just practice this. Now, if all the particles are lying on the x-axis, I just need to find the x coordinate center of mass. This will be m1 x1 plus m2 x2 up to any number of particles there are over m1 plus m2 up to whatever number of particles there are, right? Now, similarly, how do we find the y coordinate of the center of mass? We say m1 y1 plus m2 y2, the sum of all this, over m1 plus m2, that is the sum of the all the masses. See, now can you guess what ZCM will be?
M1 Z1
M1
M1 is at 1, M2 is at
M2 Z2
on
Right. It goes up to whatever
M1
particles
plus
are at M1 plus M2. Right. Very good. So just wrote this down and we'll practice this using some examples. So whenever we have particles in a three-dimensional space, the center of mass may have three separate coordinates and we have to find them separately: x, cm, y, cm, and z, cm. This is how we deal with discrete masses. We'll just take a numerical example and we'll practice it, right? Have you noted this down?
Yes, sir.
Okay.
The 1 minute show, sir.
Excuse me.
The 1 minute show.
Okay. Okay. You can go back. Can you see this?
Yes.
Okay.
Yes, sir.
Okay. Now, we'll practice how to actually do this, right? So let's say I have particles. I have a 1 kg particle, which is located at 2, minus 3, 0. Let's say a 1 kg particle. These are the coordinates it is located at. Now I have a 2 kg particle. It is located at 3, 1, minus 1. Let's say right now I have just two particles in a system, and if I calculate xcm, I will write m1x1. So m1x1 will be 1 times 2. I will write m2x2. It will be 2 times 3. And what will be the denominator? What will be the denominator? M1 plus M2. It will be 3, right? So this is 6. This is 8. So the coordinate of center of mass, x coordinate, is 8 by 3. Now it will have the same units. Now if these are meters, so this will be meter. This is centimeter, this will be centimeter, right? Now, y of the center of mass, y coordinate of the center of mass. What should I write?
-3
Minus 3, very good.
plus
Plus 2, very good. Over 3, right? So it will be 1 over 3. 1 over 3. Now, similarly, ZCM, it will be what?
0
It will be 0, very good. 0. And minus 2 over 3. Over 3. Minus 2 by 3. So now we have the exact idea where the center of mass of these two particles should be. Write this down, then I'll tell you just one or two points about center of mass, which we should always keep in our mind. They are only a mathematical common sense that we should have regarding center of mass. Just note this down first, right?
Sir,
Yes.
Sir,
sir,
why
y
is
coordinate
minus-
-1.
In the y coordinate, minus 1 by 3. Yes, sorry, my mistake. It should be minus 1 by 3. Yes. Thank you for pointing this out. It is minus 1 by 3. Yes, of course. It is minus 1 by 3. Please correct this. If you have written 1 by 3 like me, please correct this. Minus 1 by 3. Right. So everybody has noted this down?
Yes, sir.
Okay. Now we'll just write 2 points, which are nothing but a basic common sense about the location of center of mass. See, the first point is, if a system consists of 2 particles only, write this down. If a system consists of 2 particles only, see, in a system I have only 2 particles. If a system consists of 2 particles only, their center of mass must lie on the line joining them, on the straight line joining them, Let's say if I have M1 and M2, where should the center of mass be? It should be on the straight line joining M1 and M2. It should be on the straight line passing through M1 and M2, right? It can't be here, it can't be here or anywhere else. It has to be on the straight line joining M1 and M2. Okay, and it should be in between their location. In between, it can't be
Sir,
on
after
this.
center of mass must lie.
Must
Can
lie.
you say once again? Say
Okay, I'll
once
repeat
again,
that.
sir.
If we have a system consisting of two masses, their center of mass must lie on the line joining them. On the line joining them. See, I have 2 points. There will always be a line that joins them. This is that line that passes through the location of M1 and M2. The center of mass must always lie on this line. That is the first point we are saying. Another thing what we are saying is it should lie in between their locations, in between. Center of mass can't be on this, although this is on the line. Center of mass can't be at this position, although it is also on the line. The center of mass should be where? Center of mass should be where? In between. It should be in between the two masses, somewhere in between. It can be here. If M2 is heavier, it can be here. If M1 is heavier, it can be here. On this side, right? It does not always need to be right in the middle. No, it will be towards the heavier mass, but it has to be in between. Okay, so this is that only a common sense kind of a thing that we need to keep in our mind, right? Everybody has understood that this point?
Yes, sir.
Okay, now the second common sense aspect is, let's say if I have 3 masses, what do I have? If I join these lines, I have a triangle, right? I have a triangle. So the rule says if we have 3 particles, the center of mass should lie somewhere inside this triangle. I'm not saying right at the center of the triangle. That will only be the case when the masses are same, right? But if we have any masses, any 3 masses, if we join them using straight lines, we'll obtain a triangle. We'll obtain the center of mass somewhere in between this triangle, right? Just note this down, that if a system consists of 3 particles, the center of mass must be somewhere inside the triangle. The center of mass must be somewhere inside the triangle formed by joining their positions 2 at a time. Joining their position 2 at a time. If we take 2 at a time, we get a triangle. The center of mass must be somewhere in between this triangle. So this is called the concept of enclosed space. If we have any number of particles, they always constitute an enclosed space. See, if I have these many particles, this is the space that is enclosed by this particle. So the concept says center of mass will always be inside this enclosed space. It can never be outside this enclosed space. Do you get my point?
Yes, sir.
Okay. So now, another very interesting aspect we'll learn is, okay, write this down. Center of mass of a 2 particle system, I will tell you some concepts which are very useful and which are asked very frequently in JEE and NEET. Center of mass of a 2 particle system. Let's say I have a system which consists of only 2 point masses. One is M1 and one is M2. Okay. And let's say the distance between them is L. We can write this as X also. We say let the distance between them is L. Okay. Note this down. Now, if M1 There is M2 and this is L. What if I consider M1's location to be the origin? What will be M2's location? It will be L comma 0, right? L comma 0 comma 0. I can say that. Okay. Now, let's say I have center of mass at this position, and let's say this is called x1, distance to center of mass from M1. What will be the value of x1? It will be M1 times 0 plus M2 times L over M1 plus M2, right? M1 plus M2. So x1 will be how much? X1 will be M2L over M1 plus M2. Just make sure that this is correct, right? X1 is M2L over M1 plus M2. Noted this down?
So 1 minute, sir.
Sure. Take your time.
Yes, sir, finished.
Okay. Now, x1 is the distance of center of mass from M1. What is this distance? Let's say this is x2. X2 is the distance of center of mass from M2. Now, is x1 plus x2 equal to L or not? Yes, it is. X1 plus x2 is equal to L. So what is x2? X2 is L minus x1. So L minus M2L over M1 plus M2. Can you solve this for me, please? Can you solve this? It is M1L, yes, M1L over M1 plus M2. So this is x2. Now this is x1 and this is x2. Write this down and we'll discuss a very interesting fact about the ratio of x1 and x2. See, in the expression for x1 as well as x2, the part L over M1 plus M2 is common, right? Firstly, have all of you noted this down? Exactly like
Yes,
this. Okay. So I'll go to the next page, but you have in your notes the value of x1 and x2. So if I just take the ratio x1 over x2, it will come out to be M2 over M1. Isn't it? X1 over X2 is M2 by M1. Now, this is a very interesting fact about a system of two particles, that the center of mass is dividing L. L, what is L? It is a distance between M1 and M2. The center of mass is dividing this distance in the inverse ratio of masses. Write this down and I'll talk about this in numerical terms. Okay, just write this statement down. The center of mass of a two particle system, the center of mass of a two particle system divides the distance between them, in inverse ratio of the masses, Written down?
Sir, once again, sir.
Okay, should I repeat?
Sir, yes, sir.
Okay, the center of mass of a two particle system, divides the distance between them, in inverse ratio of the masses, in inverse ratio of the masses.
Sir, after inwards.
Not inwards, it is inverse ratio of the masses, right? Of the masses. I will give many examples of this. First, note this down. Inverse ratio of the masses, right? Everybody okay with this?
Yes, sir.
Okay. Now let's apply this. What do we mean by this? Okay. How do we need to remember this? Let's say I have a 1 kg mass and a 3 kg mass. So the ratio is 1:3. See, you see 1:3, right? And let's say the distance between them, let's say the distance between them is 10 meter. Okay, where do you think center of mass should be? Near the 3 kg mass or near the 1 kg mass?
Near 3
Near the
kg.
3 kg mass. So it should be here. Okay. Now, what this concept says that this 10-meter distance has been divided in the ratio of 3:1. This is 3, the longer part is 3, and the smaller part is 1. This is the inverse ratio. On 1 kg side, the distance is 3. On 3 kg side, the distance is in the ratio 1. Now, can you divide 10 in the ratio 3:1? Can you do this?
8 and 2, sir.
No, it won't be like this.
7.5 and 2.
7.5 and 2.5. Yes. Please do this. For those students who are out of touch, using ratio proportion, I'll just tell them that how do we divide in 3:1? It means that we have divided the entire distance in 4 parts. 3 plus 1. 3 parts have gone to this side and 1 part has gone to this side. So the 3 part is 3/4 of 10. And the 1 part is 1/4 of 10. Are you following the method?
Yes, sir.
Okay, so this becomes 7.5 and this becomes 2.5. See how easy this is? See, okay, just for practice, let's say I have a 2 kg mass and I have a 4 kg mass. 4 kg. The moment I say this, you should realize the ratio is what? 2 and 4. The ratio is what?
1:2.
1:2. So the center of mass, it will divide this distance in 2:1. 2:1. Now, whatever the distance could be. If the distance is 6 meter, let's say the distance is 6 meter, what will be the division 2:1? What will be this division? 4 and 2. 4 meter and 2 meter. 4 meter and 2 meter, right? 4 meter from the 2 kg mass and 2 meter from the 4 kg mass, right? So are you getting this concept that whenever we have a system of 2 particles, the center of mass divides the distance between them in what ratio? In what ratio?
M2 by M.
2:1.
No, not always 2:1. It will be inverse ratio of masses, right? And what do we mean by inverse ratio? That the larger distance will be from the smaller mass and the smaller distance will be from the larger mass, right? Inverse ratio. Are you comfortable with this inverse ratio? Can I ask you a question regarding this?
Yes, sir.
Okay, let's go. Let's say I have a 1 kg mass and I have a 6 kg mass, and they are separated by a distance of, let's say, 4.9 meters. 4.9 meters. This is the center of mass, let's say. What is its respective distance from 1 kg and 6 kg? 4.9 meters. Anybody?
0.8.
0.2 and 0.7, sir.
It will be 4.2 and 0.7. Is everybody getting this answer? 4.2 and 0.7?
Yes.
Yes, sir.
Everybody? Okay. So I can be assured that, now you got the point. So this is a very useful concept and we'll keep using it in this chapter, right? System of two particles, right? Now we'll come to another aspect of center of mass, that is called displacement of center of mass. Displacement of center of mass. What do we mean by displacement of center of mass? See, in a space, if we have different masses, there will be a unique point which is called the center of mass law. Now, if due to any reason these masses they change their position, see, if m1 goes to m1 dash, m1, so not m1 goes to m1 dash, m1 changes its position from r1 to r1 dash, it goes to this position. Now m2, it goes to some other position, let's say it goes to this position, and m3, it goes to some another location, r3 dash. Okay, now everybody has moved, so there is a chance that center of mass also might have moved, right? So how do we calculate the displacement of center of mass? In the same way that we calculated the position. So displacement of center of mass is denoted by delta r. Delta represents change, Cm, that is change in the position of center of mass, and the formula is again of the same weighted average, m1 delta r1 plus m2 delta r2. If there are more, we'll keep on adding, divided by m1 plus m2 up to whatever number of masses there are. Note this down and we'll further simplify it. Now, what is delta R1? Just we'll get an idea about this. This is R1 final minus R1 initial. What will be delta R2? It will be R2 final, the final position of particle 2, minus R2 initial, the initial position. Now, that way we can write all these delta R, right? Noted?
Yes,
Yes.
sir.
Okay. Now, if you are only dealing with delta XCM, let's say we are only interested in knowing what is the change in the X coordinate of center of mass, our formula will modify to M1 delta X1, right? Plus M2 delta X2 over M1 plus M2, right? Similarly, if I'm only interested in the change in Y coordinate, it will be M1 delta Y1 plus M2 delta Y2 over M1 plus M2. See, similarly, you can write the expression for delta Z, but that is very obvious. Note this down. Then we'll discuss another interesting aspect of this. And keep this in mind that in all these formula, there is a common theme that the greatest contribution comes from which mass? The greatest contribution comes from which mass?
Heavier.
The heaviest mass, right? Whether it is the actual position of center of mass or it is the change in the position of center of mass, that is the displacement, the most severe effect comes from the heaviest mass. Who is contributing the most? The heaviest mass is contributing the most. So, noted?
Yes, sir.
Okay. Now, under this discussion, we can discuss a very interesting scenario. See, write this down. Cases where the center of mass does not displace. These are very interesting cases in physics, cases where center of mass does not displace. Write this down. I'll give you a few examples. All of you are familiar with Newton's first law. Am I right? Newton's first law.
Yes, sir.
Okay. Can anybody explain to me what Newton's first law was in very brief discussion? What Newton's first law is? What does Newton's first law say? Anybody? Newton's first law used to say it said a particle at rest, an object. Okay.
Net force is equal to zero.
Okay.
Acceleration is equal.
Exactly. If an object is acted upon by no external force, if there is no external force acting on an object, what does it not do? It does not get displaced, or it does not change the direction in which it is moving, right? Am I right? Similarly, we can modify this Newton's first law for a system of particles. See, Newton's first law for a system of particles. What does this say? Let's write this down. If a system of particles experiences no net external force. If a system of particles experiences no net external force, comma, there will be no displacement of its center of mass. I will give you many examples of this. First, I will repeat this. If a system of particles experiences no net external force, there will be no displacement of its center of mass. Clear?
Yes, sir.
Okay, now let me explain this. We are saying we have a system of particles. Let's say we have a system in which there might be 2 particles, 3 particles, 300 or 3000 or any number of particles. There is a scenario in which the particles are being exerted upon by forces. Let's say there are forces F1, F2, F3, but the condition is F1 vector plus F2 vector plus F3 vector is 0. This is called the net force on the system being 0. So if this is the scenario in which there might be forces on the individual particles, but the sum of those forces is how much? 0. The particles could move. The particles being acted upon by forces, so according to Newton's first law, they can move. But what will not move? The system's center of mass. See? Okay. Now let's say the particles were on the vertices of an equilateral triangle in the beginning. The forces were given to them. This went this way. This went this way. Just a moment, beta. This went this way. Now the particles are here, here, and here. Have the particles moved? Have the particles got displaced?
Yes, sir.
Yes, but the center of mass was at the centroid earlier. It is still at the same centroid right now. Now you can come up with your question, son. You're going to ask something? Somebody was asking me
So
something.
that example one more time again.
Okay, I'll give you this example. That's that we have three particles and they are being acted upon by three forces which are pushing them out. Okay, so M1 gets displaced to this position, M2 gets displaced to this position, and M3 gets displaced to this position. But the sum of the forces is how much? Sum of the forces is how much? 0. If the sum of the forces is 0, the particles will reach new positions, but the center of mass will remain at the same position as earlier. This is the concept I'm telling you. If there is no external force on the system, not on individual particles, on the system, what will remain stationary?
Center of mass.
Center of mass will remain stationary. I'll give you another very practical example. Have you seen a firecracker? A firecracker? Or if you play some online games, you must have seen a hand grenade.
Yes, sir.
Okay. Now we'll take the example of a hand grenade or a firecracker. Let's say this is a hand grenade, this is a particle, and what happens when we trigger it? Some internal chemical reaction happens and it explodes. So this was an intact particle. Let's say this is its center of mass. What will happen when it explodes? It will break down into thousands of particles, sometimes some millions of particles, and each particle will fly off to a very different location. The fragments will fly off any which way they want to, right? Now, whatever happened internally. Did we apply any external force to the hand grenade? It was placed at a point, it was detonated, it was made to explode. There was no external force on it. It was lying stable, right? So when it exploded, all the forces, where did they come from? They came from inside. Those are called internal forces. There is no external force on the system. So even if the fragments fly off to any which way they want to, what will remain at the same point? What will remain at the same point? Center of mass. Okay, so for simplification's sake, let's say this hand grenade breaks down into 4 parts. This and this, 4 parts. This one goes this way, this one goes this way, this one goes this way, this one goes this way. See, now these are the final locations of the 4 fragments. Where will the center of mass be of these 4 fragments? Where do you expect the center of mass of these to be? At the same point where it was earlier. If this was the center of mass earlier, this is still the center of mass now. Can you understand my point?
Yes, sir.
Okay. Now, after knowing this, how can we use this in numerical problems? What kind of questions can we solve using this concept? See, so we'll take one question. The question is, there is a plank, a wooden plank, on which a person, okay, anyone, a person of mass small m, the plank has a mass capital M. See, and for argument's sake, let's assume the plank is of uniform mass distribution. So center of mass will be right at the center, right? So a man is standing on a plank and the plank is placed on a frictionless floor. Write this condition down. Man or a person is standing on a plank. A person is standing on a plank and the plank is placed on a frictionless floor. Now, during your study, you will always come across such kind of questions where the plank is always on a frictionless floor. Why do we need this frictionless floor? Can anybody guess? Why do we need this frictionless floor for the question to proceed further? Why do we need this floor to be frictionless? Anybody?
Sir, because kinetic.
Because of what?
Since it is an external force.
External force, right? If
Center
the
of mass
center of mass will, okay, exactly. We need the center of mass to remain at the same point. For that, we need external force to be zero, or to be more precise, we need horizontal external force to be zero. Okay, so in order to ensure that the friction should be absent, or the plank must be on a frictionless floor. See, practically, there are very less scenarios and we can actually save a frictionless floor, but let's assume our floor is frictionless. So what will happen? The process of walking, let's understand the process of walking. The person will exert a backward force with his feet on the plank. So as a reaction, the plank will exert a forward force on the man. So man will move this way. Where will the plank go? Where will the plank go?
Backward.
Backwards. Very good, right? The plank will go backward. This is happening. Why? Because they have to maintain a condition in which the center of mass of the system. See, if the man's center of mass lies on this line, let's say this is the man's center of mass. This is actually the x coordinate of center of mass of the man, and this is the plank center of mass. So the system center of mass must be somewhere here. So they are maintaining a condition in which always, wherever the man goes, the center of mass always remains at this point by adjusting the position of the plank. So plank is placed on a frictionless floor. Now, what is the real question? The question is, see, let's say the length of the plank is capital L. What will be the displacement, right, is not complete displacement of the plank when the man reaches the opposite end, See, write this down, and I'll tell you one standard method to solve all these kinds of questions. You just have to practice it. Okay, so write this down. I hope everybody understands this question, that a man is standing on a plank. The man is standing on a plank. The plank is kept on a frictionless floor. The man begins to walk on the plank. The moment the man does this, the plank starts sliding backwards. So when the man reaches the other end, the man reaches the end, what we are asked, what will be the displacement of the plank by this time? Okay. Now, note this down. Has everybody noted it down?
Yes, sir.
Okay. Now, we'll come to the solution of this problem, and always remember this solution. And if whenever you have a doubt regarding this, okay, you can ask me and we can discuss it further. But it's a very simple mathematical problem. See, what we will do is, in the initial condition, let's say this is the initial condition, we have taken this as x-axis, y-axis, this is the man. We have taken this point to be the origin, 0, 0. So the coordinate of man at this time is 0. The x coordinate of plank at this time is L by 2. Do you agree with me? L by 2. The coordinate of center of mass of the plank is L by 2. Do you agree with me?
Yes, sir.
Okay. Now, what we'll do is we'll assume, although we know that the plank is going leftward, but just for mathematical sake, let's say we'll assume that the plank gets displaced by a distance x. And now this is the final situation. This is the final situation in which the plank is at a distance x from the origin. Where is the man right now? On the left corner or the right corner? On the left corner. It was initially at the left corner, finally on the right corner. The man has moved to the right corner. So what is the coordinate of man right now from the origin? This is the origin. How far is the man from the origin?
L plus x.
L plus x. Okay. L plus x. Very good. Now, what is the coordinate of the plank center? How far it is now? It was L by 2 earlier. How far it is now?
L by 2 plus x.
L by 2 plus x. X plus L by 2. Note this down, then I'll come to the formula part of it. Okay. Some of you might be wondering why I have taken the blank to have moved to a distance x to the right, when in reality we know that the blank is moving to the left. What my answer to this is, we are assuming the distance x, we are not saying it is positive. After solving this, if x comes out to be negative, we will automatically know that the real displacement is not to the right, it is to the left. So whenever we are taking an assumption, always take the assumption to be positive by default. Now wait for the process to be completed and the answer to come to you. And if in reality x is going to be negative, it will come out to be negative. You don't have to bother about it. See, so what does that formula say? It says m1 delta x1 plus m2 delta x2 over m1 plus m2 should be zero. Should it be zero or not? This is the formula for displacement of center of mass. And how much is the center of mass supposed to displace? Zero. It is not supposed to get displaced at all. So we are using m1 delta x1 plus m2 delta x2 equal to 0. Now how do we write this? m1. What is m1? The mass of the man, m. Delta x1, final position minus initial position. So x plus L minus 0. See, the final position of man is x plus L. The initial is 0. So it is x plus L minus 0 plus m2. What is m2? The mass of the plank. What is the displacement? Delta x2. Final position minus initial position. X plus L2 minus L2 equal to 0. Note this down and understand this. Get to know this. Learn how to use this. Final position minus initial position. M times final position minus initial position. And the summation of this will always come out to be 0. So let's further simplify it. Mx plus ml. Now L by 2 gets cancelled. Plus capital Mx equal to 0. Now what is x? It is m plus m. Okay, this should be capital M. This should be capital M. It should be minus ml over small m plus capital. See, if I have solved this in the correct way, x equal to minus ml over m plus n.
Yes, sir.
Now, is the answer coming out to be negative or not?
Yes,
It is,
sir.
yes. So we don't have to bother about right or left. We just assume x to be positive and we wait for the answer to come to us. So the answer is explaining itself that x is negative. That is, the plank has moved to where? Right or left? To the left. To the left. So it will come out all by itself. So do you understand this? Are you having any doubts regarding this? How to use this?
No, sir.
Okay. Should I give you another example to solve for yourself?
Yes, sir.
Yes, sir.
Have you noted this down?
Sir, no, sir.
Okay, please note this down. Okay. And I will just change a few conditions in this question and I will ask you what should be the answer now. Always use the standard method and your questions will come out perfect. Okay. There is no scope of getting a wrong answer because we have left everything to the maths. And if our maths is correct, the answer will always be correct.
Sir,
Yes.
sir, in the third step, how it is capital M L, sir?
Sir, it
Okay.
is small L, a small M.
It should be capital M. Okay. It should be small ml. Okay, right? Yes. This was a mistake on my part only. It should be small ml. So answer should also be small ml, right? Small ml. Yes, right. Please correct this. Yes. It should be small ml of m plus. Yes. Absolutely right. Okay, so have you noted this down right now?
Yes, sir.
Okay.
Yes, sir.
I'll just change a few details in these questions and we'll solve this. Okay. Now, instead of one person on the plank, let's say we have a situation in which there is a uniform plank of mass m and length L, and we have two persons. We have M1 on the left end and M2 on the right hand side of the plank. See, draw this. This is our initial condition. Again, the plank is supposed to be placed on a frictionless floor so that there is no horizontal external force on this entire system. Always think about the system. What does this system consist of? How many masses are there in the system? How many?
Two, sir.
Three. M1, M2, and L. Sorry, M1, M2, and capital M. They are all part of this system, right? Do you understand me?
Yes,
Yes,
sir.
sir.
Yes. Always think about the system as a whole. The system is made up of three constituents: M1, M2, and capital M. Okay. Now this system is placed on a frictionless floor. There is no external horizontal force. So the individual particles can move. M1 can move, M2 can move, Planck can move. But what cannot move? What will remain stationary?
Center of mass.
The center of mass. So my question is, what will be the displacement of the Planck? Find the displacement of the Planck if M1 and M2, that is the two persons, exchange their positions. That is, M1 goes to the right corner and M2 comes to the left corner. If this happens, what is the displacement of the Planck? Have you understood this question?
Yes, sir. Yes.
Okay. So let's begin. In the initial condition, let's mark the positions of all the particles, M1, M2, and the center of the Planck, M. Now this is 0, this is L by 2. What is this? What is this? What's this coordinate? 0, L by 2. What is this coordinate?
L, sir.
L, yes, right? Now, since we are not bothering ourselves with where the Planck will go, we'll just assume it goes to a distance x, and now this is the position of the Planck. So the center is here. What is its coordinate? X plus L by 2 right now, right? X plus L by 2. Now, where is M1? Where is M1 right now? Here or here? To the left, to the right?
Sir.
Right. Okay.
Right.
This is M1 now. So what is the coordinate of M1 now?
X plus L.
Plus L, sir.
X plus L. Very good, right? And what is the coordinate of M2 now?
X, sir.
Only X. Yes, very good. So can you apply this formula now? M1 delta X1 plus M2 delta X2 plus capital M delta X equal to 0. Can you do this for me?
Yes.
Okay, let's begin. So we'll write M1 into final coordinate minus initial coordinate. What should I write in the bracket?
Plus L minus
X plus L minus 0. See, X plus L minus 0 plus, what should I write in the M2 bracket? M2 bracket.
L
X plus L by 2
X plus L by 2 minus how much?
minus L.
Minus L, very good. Plus capital M bracket, what should I write? X plus L by 2 minus L by 2 whole equated to 0, right? See, keep on practicing this along with me, and wherever you have a doubt, come up with it that I will explain it to you again. So this is the expression. Now we come to the solving part. Let's collect the x's together. X, x, and x. So m1 plus m2 plus m times x. Now let's collect the l's together. M1l, M1l. Now this is plus L by 2 or minus L by 2. What is this? Plus L by 2 or minus L by 2?
minus L.
Minus. This is minus. Oh, this will be 0, no? X plus L minus 0. So M1L, right? Okay. So this is minus M2L by 2. Now here, there is no L part in this. There is no L part in this. C equal to 0. Can you solve for x now? What is x? What is x now? Anybody? Anybody? What is the value of x?
Sir, I didn't understand how to write M2, sir.
M2. Okay. See, M2 is now at the left corner. So its coordinate is x. M2's coordinate is x. Actually, I have taken L by 2 wrong here. M2's coordinate was only x. So it was only x minus L. So I should have written M2L here. Okay, just correct this. So M2's final coordinate is x and M2's initial coordinate was L. So it was M2x minus L. You understand this now?
Sure, sir.
Okay, right. So if we go along with this, x will be M2 minus M1, L outside the bracket, over M1, not L by 2. It is L now. See. The coordinate was x here and the coordinate was L here. So it is M2x minus L. There's no L by 2 in here. M2 minus M1 L over M1 plus M2 plus capital M. See, note this down and we'll discuss a very interesting point about what does this M2 minus M1 imply for us. Have you noted this down, everybody?
Yes, sir.
Yes, sir.
Okay, see, now our expression, how do we know X is positive or negative? So if M2 is greater than M1, this expression will be positive or negative? If M2 is greater than
Positive.
M1, it will be positive. That means where will the plank go? Towards right or towards left?
Right.
Towards right. Very good. Now, if M1 is greater than M2, M1 is the heavier person. Where will the plank go now?
Left.
To the left.
Left.
See, now whenever we have a doubt about this, had we to guess this, we would have to go through a very long analytical process. Just by using a simple mathematics, we have left this to mathematics only, and maths has explained us that don't worry, whatever the answer is will depend on M2 and M1's value. If M2 is greater than M1, the heavier person is on the right, the plank will go to the right. If the heavier person is on the left and they start moving, the plank will go to the left. See, we don't have to worry about it. Can you solve these kind of questions on your own if you encounter them in the exam from now?
Yes, sir.
See, the process is very simple. Just write down, just take one of the ends as the origin, preferably the left one, take that as the origin. Write down the coordinates of each constituent. It does not matter there are 4 people on the plank or 5 people or 50 people. Just write down their coordinates along with the center of mass of the plank itself. See, in the final situation, when the people have moved, just assume that the plank has moved by a distance x to the right and place everyone at their final position, wherever they have gone. See, if the M1 and M2, they decided that we'll meet at the center of the plank. What will be the coordinate of M2 in that case? X plus L2. What will be the coordinate of M1 in that case? Again, X plus L2. See, so we don't have to bother. We just place them wherever they go and we write the final coordinates. Now, what do we use the formula? M1 final position minus initial position, M2 final position minus initial position, capital M final position minus initial position, and the sum is equated to 0. Whatever the solution comes out, it will be self-explanatory. It will explain positive, it will explain negative. If M1 and M2 are of equal masses, what will be the value of X?
0.
0. It means the plank will not move at all. The plank will not move at all if M1 and M2 are of equal masses. You get my point?
Yes, sir.
Okay, so I hope you can solve these kind of questions whenever you face them. Okay, we'll move on to our next concept. Another very important concept for exams, that is, write this down, rigid bodies having uniformly shaped cavities. What is this concept? Let's discuss this. Uniformly shaped cavities. Okay, first we'll discuss a very simple point, that if we have a uniform rigid body, what is this? This is a uniform rigid body. What do we mean by uniform? That means the mass is distributed evenly over the entire space. The mass is distributed evenly. The mass distribution is even. It is not uneven or somewhere there is more dense mass or less dense. No, the density is evenly distributed. So if I say the center of mass of such a body, a uniform rigid body, must be at the center of symmetry, at the center of symmetry. Am I wrong in saying this? What do we mean by center of symmetry? It means the physical center of the object. So if it's a disk, where will the center be? The center of the circle. If it's a solid sphere, let's say it's a solid sphere, again it will be at the center of the circle. See, if it's a triangular plate, which is equilateral triangle, the center of symmetry will be the centroid. So can I say the center of mass of a uniform rigid body is always at the center of symmetry? Can I say this?
Yes, sir.
Yes. Okay. Now, what do we mean by uniformly shaped cavities then? Okay. So let's say we have a circular disc. We have a circular disc. From this circular disc, we take another smaller disc out. Now, this part is solid. This part is hollow. There is nothing here. Just look at the shape of this cavity that we have formed, the part we have removed. Is it a uniform shape or a non-uniform shape?
Uniform.
Uniform shape. So this is what we are discussing, that how to locate the center of mass of such a rigid body that is having a uniformly shaped cavity in it. See, note this down and we'll proceed with the method how to solve this. I've written rigid, I should write rigid. Okay, have you noted this down, everybody?
Yes.
Okay. So let's get along with the method. What do we do? See, we'll take this example of a disk. Let's say, after removing this mass, we are left with this mass only. Let's say this part, that is the remaining mass, has its center of mass at a distance x from the original center. Let's call this O. This is our center of mass. Let's call it C dash. C dash is at a distance x. Why has it moved to the left hand side? Can anybody explain it to me? Why the center of mass of the new shape has moved to the left hand side? Can anybody tell me about this?
Because more mass is present in this.
Because more mass is present on the left. When there was no cavity, the mass was distributed uniformly to the left and the right of the point O. If I draw this line, just look at this. If I draw this line, before removing the mass, was the mass on the right equal to the mass on the left? Yes.
Yes, sir.
Yes. Now, after removing this, this is the heavier part. That's why the center of mass is supposed to be at C dash. Am I right? Okay. Now, for just a moment, bring back the removed mass. This is the removed mass. Let's bring this back. We are bringing it back. So the center of mass of this removed part must be at this point. Let's call it C naught. The removed part is called C naught. So the removed part has a center of mass at the center of the small disk, that is C naught. What is this distance? Can anybody tell us? If this is capital R, so what is this distance? What is this?
R by 2.
R by 2. Very good. This is R by 2. Okay. Now this is X, this is R by 2. Just draw this figure. If you have any doubts regarding this figure, I will explain it to you in more detail, but I think you should understand this. Draw this. Okay, has everybody drawn this figure?
Yes, sir.
Okay. So just tell me this, whether I'm right or wrong. The center of mass of this portion, which we are trying to find, combined with the center of mass of this removed part that we have brought back, should it not be at point O again? Center of mass of this combined with center of mass of this should be at O. Am I right or wrong?
Yes, sir.
Yes. So now we come to the mass of these two. If the entire disk was of mass capital M, if the entire disk was of mass capital M, the smaller disk, so we'll call this entire disk. Entire disk. So the smaller disk, what should be its own mass? I am saying it should be m by 4. Just go along with my logic. Why this is m by 4? The radius of the smaller disk is half the radius of the entire disk. Right or wrong?
Yes, sir.
Right. So if the radius is half, the area is how much? 1/4, right or wrong? The area
Yes,
is
sir.
1/4. So since the mass of a disk is directly proportional to the area it has, if the mass of the entire disk is m, the mass of the smaller disk must be m by 4. Am I right or wrong?
Yes, sir.
Yes. Everybody is getting this point. We are relating the mass to the area. Mass is area times surface density. Let's call it sigma. So greater the area, greater is the mass. So the entire disk has an area pi r square. The smaller disk has an area pi r square by 4. So the area is 1/4. So if the area is 1/4, so is the mass. So this is m by 4. What is the remaining portion? It should be 3m by 4 or not? Am I right? Now, what is my concept now? That 3m by 4 multiplied by its center of mass is coordinate x. I'm assuming x to be anything. It will come out to be negative, positive, whatever it actually is. I'm just putting it as x. 3m by 4 times x plus m by 4 times its center of mass, that is r by 2, divided by the total mass, that is m, should give me a coordinate 0, because I've taken the center of mass to be at 0. At this point 0. Is this equation right? Is this equation acceptable to everyone?
Yes, sir.
Okay. So when we solve this, x comes out to be minus r by 6. See, m by 4 gets cancelled out. 3x is equal to minus r by 2. So x is minus r by 6. What does this negative sign imply? Can anybody tell me? What does this negative sign imply?
It moves towards the left.
It moved towards the left. See, I don't have to bother about the fact that it will move towards the left. It will come out by itself. See, just note this down. And the most important part is the ratio of masses. If this is m, this is m by 4. If you get this, you will get this concept. We'll apply it in so many cases. You will get enough practice of this. But first, understand this one question. If you have any doubts, please come up with it. We'll discuss it in more detail. Any doubt?
Sir,
Yes. Go ahead.
sir, what if the hollow part is taken from the center? Where will be the center of mass?
Okay, I'll draw another figure for you and tell me if I'm drawing it correctly or not, right?
Yes, sir.
So where should I remove the mass from? Exactly symmetrical to the center or towards a bit to the left or bit to the right?
Exactly symmetrical.
Exactly
sir.
symmetrical. Okay, see exactly symmetrical. What do you expect now? I have removed mass symmetrically from left, from right, from up, from down. Should it disturb the position of center of mass? What does your common sense say? Should it disturb the symmetry? Should it disturb the center of mass's location? Just guess. Should it or should it not? What do you think?
It won't disturb the
It won't
center of
disturb
mass,
the
sir.
center of mass. Why? Because we have removed mass symmetrically. If we have removed something from right, we have removed something from left. If we have removed something from up, from above the axis, we have also removed the same kind of mass from below the axis. So if we are removing, or if we are making a cavity that is symmetrical around the center of mass will not get disturbed. But if it is removed in an unsymmetrical fashion, see, if my disk is removed this way, where will the center of mass go? Where will the center of mass go?
Shift downward.
It will shift
Down,
downward.
sir.
Very good. See? Okay. So have you understand this concept, everybody? Everybody?
Yes, sir.
Okay.
Yes, sir.
Okay. So can I, with your permission, try to make this question a bit more challenging for you?
Yes.
Just a bit, not too much, only a bit. Agreed? Okay, thank you. Now we are taking the same uniform disk, but this time the cavity that we are removing, it's at one corner, but its radius is only r by 3. How much is its radius? R by 3. In the previous example, the radius was r by 2. It was coming up to this point. But right now its radius is only how much? R by 3. Okay. Can you guess this center's location, how far this is? If this is entire R, this is R by 3. What is this distance? What is this distance?
2r by 3.
2r by 3. Okay. So I have removed a cavity which is of a radius r by 3 from a disk of radius r. Now, can you look at the center of mass? Center of mass will get shifted to which point? Right or left of the center?
Left.
Left of the center, we know that. So are you going to try this on your own? And then I will discuss what you have done, right? Just try it once, okay? Or maybe try it with me. I'll ask you a few questions about this. If the entire mass of the disk is m, what is the mass of the cavity? Based on the radius, what is the mass of the cavity? Anybody? Fast guess. If this is entire mass is m, what is this?
M by 9.
M by 9. Very good. The mass is m by 9. Anybody having a doubt how we arrived at this conclusion? M by
Can I
9?
explain, sir?
Yes, please. Yes, please. Yes, yes. See, when we write the area, we write pi r square, right? So the entire area is pi r square. What is the small area? It is pi r square over 9, right? R by 3 square. See, there is a difference of a factor of 1 by 9. No? 1 by 9. So if the area gets reduced by a factor of 9, the mass also gets reduced by a factor of 9. Okay.
Yes, sir.
Right. So this thing is of a mass m by 9. So the remaining mass must be how much? 8m by 9. Am I wrong or right? 8m by 9.
Yes, sir.
Now this 8m by 9 is supposed to have a c dash or a center of mass at a distance x from the origin, the original center of mass, and the cavity is supposed to have its center of mass there at 2r by 3. See, 2r by 3 from the center. This is our geometry. So what does the formula become? 8m by 9 multiplied by x plus m by 9 multiplied by 2r by 3 over the complete mass equal to 0. This will always get multiplied to become 0. So we are not bothering about it. But anyway, the mass is n. So can you solve this and tell me what x is? Can you solve this and tell me what x is? Anybody?
16 R by 3.
16 R by 3. I'll say try once again. See, m by 9 will get cancelled by m by 9. See, it is getting put to 0, so we are not bothered about this. So 8x is minus 2r by 3. Right? 8x is minus 2r by 3. So x will be how much? Minus r by 12. Minus r by 12. Again, the minus sign is explaining one thing only, that the center of mass has shifted to the left. We are expecting this. Now, just look at this r by 12. What was the answer last time? If anybody could remember or look at their notes, what was the answer last time?
Minus R by 6.
It was
R by
minus
6.
r by 6. Okay. So last time the center of mass shifted by r by 6. This time it shifted by r by 12. This time it shifted by a lesser distance or greater distance?
Lesser.
Greater distance.
Lesser distance. See, it's shifted by a lesser distance, r by 12 as compared to r by 6. Why did it happen? Because the cavity that we have removed was of a lesser mass or a greater mass?
Lesser mass.
Lesser mass.
Lesser.
So if you remove a small mass, there will be a small change. If you remove a large mass, there will be a large change. Some things, we can conclude just by a basic common sense. See, so everybody okay with r by 12 and the minus sign?
The house are from R by 12 it came. From 8x is equal to minus 2 by 1.
R. See, if minus 2r by 3, 8 will come here. So it will become 4. 4 times 3 is 12, no? Am I right?
Yes, sir.
Right? Okay. And so x will be minus r by 12. Agreed, no?
Yes, sir.
Okay. So I hope you can do these kind of questions by yourself now.
Yes.
Okay. Now, just to add another point to this, this was a disk that we were discussing. Had it been a solid sphere, just imagine a solid sphere, and we are removing a solid spherical cavity from it like this. See, this is the center of the solid sphere, and we are removing a solid spherical cavity from this. Now, what is the difference between a solid sphere and a disk? A solid sphere is a 3-dimensional object. A disk is a 2-dimensional object. So in a 2-dimensional object, we are comparing mass to the area. In a solid sphere, what should we compare the mass to?
Volume.
Volume. Very good. So if this solid sphere has a radius r and the cavity has a radius r by 2, and the cavity has a radius r by 2, the mass of the solid sphere is m. Mass of the solid sphere is m. What should be the mass of the cavity? M dash should be how much? Anybody? Take a guess. Anybody?
M by 8.
Very good. M by 8. It should be m by 8. Does anybody want me to explain how m by 8 has been arrived at? Anybody?
Yes, sir.
Please. Okay, I'll do that. See, the volume is 4 over 3 pi r cube, right? See, so if this is the volume dash, the volume of the cavity will be 4 over 3 pi r by 2's cube. Now, what is r by 2's cube? 4 over 3 pi r cube times 1 by 8 times 1 over 8. So if the radius becomes half, the volume becomes 1/8. Do you get this relation? See? And if the volume becomes 1 by 8, the mass becomes 1 by 8, right? Are you okay with it, everybody? So now, had this cavity been a smaller one, had this cavity only been of a radius r by 3 compared to the entire radius r, what would be the mass of the cavity? What would be the mass of the cavity? Anybody? If this is M, the entire mass is M, what is the mass inside the cavity? Anybody?
M by 27.
M by 27, very good, right? See, this is now this question where the cavity is of radius r by 3 and the object is a solid sphere. This once came as an IIT JEE question. IIT JEE. See, so we are not solving it right now, but I would say solve it at home, at in your own time, and just discuss it with me whenever we meet next, right? I'm very sure you will be able to solve this. That we have taken a solid sphere and we have taken out a small cavity which is touching the edge and is of radius r by 3. Center wise, there is no difference. This distance is still 2r by 3. And I'm hoping you can solve this very easily. See, so just solve this and we'll discuss it whenever we meet next, right? Okay, so this concept is clear to everybody. No doubts about this.
Sir, yes, sir.
Yes, sir.
Thank you. So what we'll do is we'll go to the next topic, that is velocity of center of mass, right? Velocity of center of mass. Velocity of center of mass. So just like the position of center of mass, if the particle starts moving, the center of mass may also start moving. It's not necessary, but it may start moving. So we discuss the velocity of center of mass. Again, VCM, which is a vector, is nothing but it is the weighted average of all the velocities, that m1 v1 vector plus m2 v2 vector up to whatever number of particles we have, divided by m1 plus m2, the number of particles we have. Note this down and we'll discuss a few more things about this. Okay. Now, since velocity of center of mass is a vector, it might have three distinct components, x, y, and z. So what if we are only interested in VCM in the x direction? We will say m1 v1x plus m2 v2x divided by m1 plus m2 plus whatever the number of particles are. Now, if we are writing VCMy, I will write m1 v1y plus m2 v2y divided by the sum of the masses. Now, whenever you are writing v1x or v2x, always remember that there is still a concept of plus and minus. For example, if m1 is going this way, should I take v1x as positive or negative?
Positive.
Positive, very good. And if m2 is going this way, should I take it positive or negative?
Negative.
Negative. So always remember this positive negative concept and you'll be fine. See. This all comes down to the ability of you to use the vector idea of velocity. See, I'll just give you an example. So if you are very comfortable or very proficient with vectors, you will always find this concept to be very easy. Has everybody noted this down?
Yes, sir.
Okay. So I'll just explain with the help of a diagram how to use this. See, if a situation is given in which a particle is going with some velocity v1, making an angle, let's say 30 degree with the x-axis. Now there is another particle m2 which is going this way. This is I'll call this m1 going this way. m2 is going with some velocity v2 this way, and there is some m3 which is making, let's say, an angle of, this does not look like 60 degree, but let's assume this is 60 degree, right? I should have drawn it better like this, but anyway, this is M3 with V3. Okay. So if I'm writing VCMX, what is the contribution of M1 to that? What is the contribution of M1 towards VCMX? Anybody? Anybody? Just try. Can you resolve this into components for me? X and Y components. Anybody can do that? What is the X component of this M1 V1? X component. Anybody?
Root 3 by 2
No,
m.
that is, can I write it this way? M1 V1 cos 30, which is root 3 by 2, of course, right? Should I write it as positive or negative? Anybody? Positive or negative?
Cost
Positive, sir.
Okay, right. Now, what is the contribution of M2 in the X direction?
0.
0. Very good. This is 0. Now, what is the contribution of M3 V3 to the X direction? Anybody? M3 V3 to the X direction. It will be what? Positive or negative? First, positive, negative.
Negative.
Negative. Very good. It will be M3 V3 cos of 60 degree, right? Cos of 60 degree divided by M1 plus M2 plus M. See how simple it is. Now, similarly, if I'm writing VCMY, we'll write contribution of M1 V1 to it. What is contribution of M1 V1 to it? Positive or negative?
Sine 30.
Very good. Sine 30, M1 V1, sine 30 in a positive way. Positive contribution. What is the contribution of M3 V3? Positive, negative?
Negative.
Positive. See, the vertical component is still positive. No, it is going in the upper direction. The X component is going towards left, but the Y component is going towards up. No, so up is positive.
Yes, sir.
Okay,
Yes,
so it is M3V3 sine 60. Now, what is the contribution of M2? I forgot about M2 now. So M2, which is M2's contribution to the Y direction.
Negative.
Negative.
It is entirely in the Y direction, so it will be M2V2 whole divided by M1 plus M2 plus M3. See? So again, I'm repeating that point that it is only an application of vectors. So if you are comfortable with vectors, you'll find it very simple. If you're not, what I would suggest is just go through the concept of vectors once more, get yourself familiarized with components, X component, Y component, Z component, get familiarized with the concept of positive, negative. What is positive X, negative X, positive Y, negative Y, and on. So you will come to this conclusion that it is very easy, only a matter of using vectors. So everybody okay with this?
Sir,
Okay. Now, can you describe a situation in which the center of mass will have a zero velocity? Can you describe a situation in which the particles are moving, but the center of mass will have a zero velocity? What should be the condition under which the constituent particles are moving, but center of mass is not moving?
Sir, in case of rotating,
In case of, yes, please.
the rotating.
In case of rotating, yes, that is one example in which if a body is rotating about the center of mass, not every case, if a body is rotating about the center of mass, so every particle is moving except the center of mass, okay, or the particles which are lying on the axis are stationary, and everybody else is moving around. That is one example. See, another example would be any case in which if sigma f external is 0, one condition is there should be no external force. Another is the center of mass should originally be at rest. Originally be at rest. So if it is originally at rest and due to some internal forces, the particles start moving, the center of mass will not move. It will remain at the same position. Just like an example of a boat. Let's say we take an example of a boat. There is a boat and there is a person in the boat and the boat is in water. See, there must be some center of mass of this system. This must be the center of mass. Now, if the person starts walking inside the boat, he's going forward, coming back, going forward, coming back. And let's assume there is no frictional forces between the boat and the water, although in a practical sense, there are viscous forces, there are frictional forces, but let's assume they are very small or negligible. So if the person starts moving around in the boat will start moving around in the water. But what will not move? What will remain stationary?
Center of mass.
Center of mass.
See, so just by going through these questions, you just have to familiarize yourself with the scenarios in which this may happen. So the more questions you expose yourself to, the more comfortable you will become with this idea that there will be some problems in which the system is moving. The system is the part of the constituents of the system are moving, but the center of mass is stationary. So whenever this happens, what will happen? M1v1 plus M2v2, let's say we are having only two particles, will be equal to 0. This means if this happens, M1 can only go opposite to M2. Am I right? M1 can only go because M1v1 will be equal to minus of M2v2, right? So if we have a two particle system in which the center of mass is not moving, the condition is if one of the particles goes this way, the other has no choice but to go which way? This way. See, we'll take another example. Let's say there are two persons holding on to a very light rope and on a frictionless rope, a very light rope they have with them, M1 and M2. If they start pulling on the rope, so they start pulling on the rope will start pulling them this way. Is this an internal force for the system or external force? Anybody? For the system, is the
External force.
for the system,
Internal.
this is an internal force whose net resultant is 0, right? T and T, net resultant is 0. So let's say M1 is 40 kg, let's say M2 is 60 kg. At any instant, if I say the speed of M1 is, let's say the speed of M1 is 1.5 meters per second. 1.5 meter per second. What will be the speed of M2? Can anybody tell me?
$2.25, sir.
How? See this. 40 into 1.5 should be equal to 60 into whatever. So what is the value? Whatever. See. V is how much? Anybody?
Minus 1 meter per
Minus.
second.
Okay, minus is obvious because we have taken the direction to this. So it will be 1 meter per second towards left. See, minus is towards left, right? So this is how easy this concept is. See. So till we meet next time, we will hope that you go through some questions that I have discussed. Whatever doubts you come across, just note them down, and in the next class we'll discuss those doubts and we'll discuss another concept of center of mass. we'll know how to calculate the center of mass of rigid bodies, center of mass of non-uniformly shaped rigid bodies, and some concepts of basic integration, right? So everybody got what we discussed today?
Yes,
Yes, sir.
Any doubts that I might answer? Anybody? Okay, so until we meet next time, just practice. I hope you have some study material along with you, and if you come across any doubt, just note them down in your notebooks and we'll discuss it next time. Thank you for attending this class.
Thank you, sir.
Thank you, sir.
Thank you.
Thank
Yes, sir.